Stop right there. Are you tired of waking up with a sore back? Do you always wake up sweating in the middle of the night? This is a huge problem for so many people. Hello everyone, we are Diploma in Science students from class 15 representing Group 5 for our PHY210 assessment. Before we go any further, let's meet the team behind today's project. I am Hamisa, the Chief Executive Officer.
I am Auni, the co-founder and healthcare specialist.
Hi, I'm Zaid, the lead mechanical engineer.
Hi, I'm Aimi Akila, the lead for thermodynamics engineer.
And I am Shakir, the lead systems engineer.
Today, we are going to present an original idea based on rotational mechanics and thermophysics to showcase an entrepreneurial mindset. Introducing our invention, the adaptive thermodynamic bed.
Let's start with the first part of our assessment, components of need. What physics-related need or concept are we addressing? Well, the main problem is bad sleep. Bad sleep is caused by uncomfortable body temperature and unsupported body positions.
Exactly. To fix this, our bed use specific physics principles. From thermophysics, we use the latent heat of fusion, specific heat capacity, and heat transfer. From rotational mechanics, we use torque and moment of inertia.
So, in what real-life situations are these concepts important? At home, it helps us sleep much better, so we wake up with more energy.
But it is even more important in hospitals. Think about nurses who have to manually lift heavy hospital beds. It hurts their backs. Also, patients who cannot move often get painful bed sores because the bed gets too hot. Our smart bed controls the temperature and moves easily. It can truly help the medical field.
It is a great business idea, but how does it actually work based on physics-related principles? Let's call our lead engineers for the components of approach.
Thanks team, I will explain the rotational mechanics. Let's talk about how the bed moves. To lift the bed smoothly, we use an electric actuator motor. The physics concept applied here is torque. What is torque? It is a twisting force that causes rotation. Imagine turning this wrench, the motor spins and that spinning force is changed into a strict push to lift the heavy mattress. What equations are involved? The equation is T equal to FRS sin theta. The radius and the force work together to lift heavy weight easily. But what if a heavy person and a light person use the bed? Does the speed change? No, because we use a moment of inertia analysis. This makes sure the motor always lifts the bed at a safe and steady speed, no matter the user weight. Now let's hand it over to Amy for the cooling system.
Thanks, Zax. Okay, now let's talk about thermal physics. Normal bed are usually trap our body heat, right? But our bed is totally different because it's using a phase change material, or we used to call it as PCM layer. So the physical process involved here is the latent heat of fusion. What is the latent heat of fusion? Latent heat of fusion is the energy required to change from solid to liquid or to release from liquid to solid. Okay, for example, look at this ice water. When ice melt, it absorbs the heat from the room, right? So the water is still cool until all the ice completely gone. So our bed does the same thing. Because of why? Because when your body gets hot, the PCM layer will absorb your heat. Okay, so it changes from solid to liquid, but the bed still cool. So the equation for this process is Q equals to ml, where Q is the heat of energy, where M is a mass, and L is referred to the latent heat of fusion. Okay, but what happens if the weather is too cool, like rainy season, or how is the air distributed? So let's bring Shake as our system engineer.
Thank you, Amy. Yes, our bed is very smart. If the weather is cold, they use thermoelectric modules. They use a process called conduction to gently warm the bed, and infrared radiation to warm your feet. To spread this hot or cool air, we have this silent DC fan, which turns rotational energy into flowing air. This physical process here is called convection cooling. We also put a gel-infused foam inside the bed. This foam has a very high specific heat capacity. This means that it can take in a lot of heat before it even gets warm. So, what outcomes or effects can be observed? With all these physics working together, the bed's temperature graph stays flat and comfortable all night long. This means no more waking up sweating or freezing.
Great job, engineering team! So, because of the rotational mechanics, the bed supports your back perfectly. No more body edge.
And because of thermal physics, you get the perfect temperature.
This means perfect sleep for users at home.
And Cephal, better beds for patient in a hospital.
It is a complete system that solves a real-life problem.
Exactly. We have clearly explained the physics need and approach on how it works.
The adaptive thermodynamic bed is a perfect example of combining science with an entrepreneurial mindset. We are Group 5 from Class 15, and thank you for watching.
Bye bye!